Hi everybody, this is Mr. Murphy and I'm going to be taking you through day 2 of graphing of our rational functions. So after watching yesterday's lesson, you probably realized that most of the graphs kind of look the same, right? You had either something that looked like that or it was just reversed and you would have it going kind of in the opposite direction. Obviously this would move up and down a little bit based on where the horizontal asymptote was, but most of them took that same form. Today we're going to look at some different forms and talk about how we'll know kind of what the graph's going to look like based on the information that we're able to solve for. All right, so first problem, example 1, we've got our function there. First step with all of these is just to factor everything as best you can. So right off the bat, a little bit tricky in the sense of we have x to the third plus 1. So we've got sum of cubes, so we need to remember our rule for that. So we got x to the third plus 1, that's going to be our a plus b first, so x plus 1. Now it's going to be a squared minus ab plus b squared, right? It's always that keep change plus with that. And then that's over if we factor our denominator a little bit simpler there, right? We're going to have, that's going to be what? X plus 1 times x plus 2. All right, at this point, we can see that it's all multiplication. We can cross out our x plus 1s, and we are just left with the x squared minus x plus 1 over x plus 2. So that's our simplified version of our function. Our discontinuities, so to go back over the discontinuities, that's anything that makes any x value that makes our denominator 0. So this is at any point in the equation with our discontinuity, so including the ones that we crossed out. So that would be x of -1, -2, and that's actually it, just -1 and -2 there, right? Those are our two discontinuities, the two values of x that make our denominator 0. Now to differentiate between the two of them, which one's our vertical asymptote, which one's the hole in the graph? The vertical asymptote is always the one that remains. So that is our x equals -2, whereas the hole in the graph, this we don't write as an x equals, this is an actual coordinate. The x value of that coordinate is -1, and then we take that -1 and we plug it back into our simplified version to figure out our corresponding y value. So if we plug in -1, we square it, we got 1. Plus 1, so we basically have 3 divided by -1 plus 2, so we are just going to end up with -1 comma 3 for a hole in the graph. All right, from last lesson, the horizontal asymptote, just to quickly go over those rules, right? If the degree is larger in our numerator, that means that there is none. So in this particular case, there is none. If the degree is the same, then it's the ratio of the lead coefficients. If the degree is larger in your denominator, then it's y equals 0, and we're going to see examples of each of those as we go. X-intercepts, so this is where if we just set our y value equal to 0, it always works out that it's the factors of the numerator. In this case, our numerator is not factorable, so this would be none for our x-intercepts. And then for our y-intercepts, we set our x value equal to 0. We just plug that into our simplified version, and we should see that we have 0 comma 1/2 left there. All right, if we go to graph all of what we have so far, there's a pretty decent amount of information, then we'll talk about how to figure out the rest of it. So we know that we graph our vertical asymptote first, and always want to label these as best you can. So that's at x equals -2. You want your graph to be able to stand alone. We have -1 comma 3 as our hole in the graph, right? And then we have no x-intercepts and a y-intercept of 0, 1/2. All right, that's all we have from our given information. So not all that much. What we can do at this point is, if you're allowed to use calculators on the assessment, obviously you could plug this into your calculator and get a look at it. Key thing whenever you're plugging these into the calculator is to make sure you're using parentheses for your numerator and denominator. Otherwise, we got a little table kind of for us out there. We can see what's going on with this. So if I just plug in a couple points here, if I plug in like a x value of 1, so I did this previously, I get a 1/3 out of that, right? If I plug in something a little bit further away, if I plug in a 5, what am I going to get? I'm going to get 5 comma 3. How do I know also that this is going to kind of go back up? We know that because of the fact that there are no x-intercepts with this. So I know that when I'm drawing that it's not going to continue down. It kind of goes up like that. And again, like I said, this is something that you could put into the calculator and take a look at. If we go on, see what's happening on the left side of our vertical asymptote, we want to check some x values over there. So if I check like a -3, I ended up getting a -13 out of that. If I kept going, I think if I plugged in something further down the line, if I plugged in a -10, I got about negative 13 point, I think it was negative 13.9 or something like that. So a little bit strange, but basically what this one was doing was kind of going off like that. And that's something, again, you could verify with the calculator or by plugging in more points. So if you take just a broad look at this, it kind of looks like there's almost a diagonal asymptote. That is true on this. That's what's called a slant asymptote. That's what you're going to look at in tomorrow's lesson. So kind of keep that in the back of your mind for once you get to next day's lesson. All right, let's take it through example number 2. So obviously nothing that we can factor in our numerator. So if we just factor our denominator, this is going to be x minus 4 times x plus 2. Our discontinuities are from that, so we got discontinuities at x equals 4 or negative 2. In this case, neither one of those cross out. That means that they are both our vertical asymptotes. This is the first time that we're going to see numerous vertical asymptotes. All right, hole in the graph, nothing crossed out. That means there are none, no holes in the graphs. Horizontal asymptote, that's based on the degree. The degree is larger in our denominator, so we have a horizontal asymptote at y equals 0. X-intercept, factors of the numerator, there are none, right? If you set y equals 0, the denominator would multiply across, you'd get 0 equals 5. That's not true, so there's none. And then our y-intercept, if we plug in 0 for our x value, we can see that would come out to be negative 5/8 for that. All right, so more going on with this one. Let's start by just labeling everything first. If I draw in my 2 vertical asymptotes, our dotted lines here, so we got x equals negative 2 and x equals 4, and now we've got our horizontal asymptote as well coming across here at y equals 0. So those are all of our asymptotes. Now if we label the only other thing that we have right now is what? We have 0, negative 5/8. So let's just say that that's right there. All right, so there's really 3 different parts of the graph that we need to look at. We need to look at the left of x equals negative 2. We need to look at that area between negative 2 and 4, between our 2 vertical asymptotes, and then we need to look at the right-hand side. So one thing that's really helpful with this is really understanding what the horizontal asymptote does. The horizontal asymptote tells us end behavior of the graph, meaning as we go off to infinity or negative infinity, our graph is going to get closer and closer to that y equals 0. So what we know basically is if we find a point to the left of x equals negative 2, so negative 3, I'm just going to draw. It's either going to come down like that or it's going to go like that, right? We know that no matter what, though, it's going to go back to that 0. So as we get closer and closer, as we go further and further to the left, we're going to get closer and closer to that asymptote. So all we need to do is check a point over here, right? If we check an x value of negative 3, we can figure out if that's positive or negative, and then we'll know the rest of it. So if I plug in negative 3, I see that that's going to be a positive value when I do that. So that means that I know that this is going to come across like that. All right? If we do the same thing on the far right side, so if I plug in a value of 5, so if I plug in an x value of 5, that again is going to become a positive value. So that means that this is going to go like that. All right, so that's just understanding what the horizontal asymptote does. Now in the middle there, it's possible to cross through the horizontal asymptote. It's rare. You can never cross a vertical asymptote, but horizontal asymptote you could. So we don't know exactly what shape this is going to take, but what do we know? We know that we have this point that's already below our x-axis, and we know that there are no x-intercepts. So based on that, I don't need to worry about where this is going to go. I know it's just going to kind of go up and then come back down. If it had x-intercepts, then we would talk a little bit further about what it might do. But in this particular case, given that there were no x-intercepts and we had that one point that was already below it, we can make a safe assumption that that's going to look like that. This is something that I would also just recommend put it into the calculator, take a look at it until we get a little bit more comfortable with these. All right, let's practice with another one. So first step, example 3, a little bit more going on here, but we want to just start by factoring. So if we factor this, if we take this first trinomial here, we're going to have x minus 3 times x minus 1, so that'll kind of replace that. And then on the denominator there, we're going to have what? That's going to be x minus 3x plus 2. All right, from here, if we cross out, the only thing that crosses out is the x minus 3, so what we're left with, x minus 1 times x plus 3, all over x plus 2 times x minus 4. So our discontinuities, anything that ever made our denominator 0. I know I'm a little bit repetitive with this stuff, but want to just make sure that we're really understanding where all this is coming from. So we've got x equals 3, -2, and 4. So that's everything. Now we break it down as either vertical asymptote or hole in the graph. So the vertical asymptote are the two factors of the denominator that did not cross out. So x equals -2 and x equals 4. The hole in the graph is the factor that did cross out. So that's our x value of 3. We take that 3, we plug it back into our simplified version. And if you do that, I believe you will get -12 fifths. All right. Horizontal asymptote, that's based on our degree. The degree in this case is the same, right? So when the degree is the same, it's y equals the ratio of the lead coefficients. These would both be x squared with the simplified version, x to the third over x to the third with our original. So 1 divided by 1, that's going to be y equals 1. For our x-intercepts, this is the first time we're seeing some x-intercepts here. So these are our factors of our numerator. So if y was 0, the denominator basically goes away. The factors of your numerator, you'd have 1, 0 and -3, 0. So that's a nice easy way to get those. And then our y-intercept, we set x equal to 0, and that is going to work out to -3 over -8, so just +3/8. This has a lot of stuff that we can start graphing, which is going to be pretty helpful to help give us an idea of what this is going to ultimately look like. So we got our -3 and x equals 1 as our two vertical asymptotes. Label those. I'm going to label at our horizontal asymptote going across here at y equals 1. We got a hole in the graph at 3, -12 fifths. So that's going to be down. We'll just kind of eyeball it a little bit. We'll say that's down there. We got 1, 0 as a, I think I did this backwards, didn't I? I put, let's correct this real quick. I put our vertical asymptotes at -3, 1. I was looking at the wrong thing there. This would be my bad, guys. Let's erase those real quick and put in our correct ones, because it didn't line up for a second there. Bear with me. As you can see, everybody makes mistakes. So we had x equals -2 as our first vertical asymptote, and then we had, let's see, x equals, that was 1, 2, 3, 4, so that'll be over here. All right, that makes a little more sense. My bad about that. All right, so if we do that, we got 1, 0, which now makes a lot more sense. And let's see, what else do we have here? We have -3, 0. All right. And then last thing, our y-intercept, we have 0, 3/8. So we'll say that's kind of right there. All right, so when I'm looking at this, my left-hand side, so to the left of x equals -2, when I'm looking at that, I already have that 1 point in there, and we talked about with end behavior, so we know that this is going to get back to that. With that 1 point there, I already have enough to know that that's going to look like that on the left-hand side. In the middle, we can see, obviously, we have this portion of the graph, which I think is kind of obvious. So now the question is this: is it going to go back down like we saw on the first page, or is it going to go through our horizontal asymptote and up? So a couple ways that you could do this. You could either plug in some points and figure it out. So if you plug in -1, I did that earlier. I believe I got 0.8 on that. So that still just puts us right about here. It still doesn't tell us for sure. But what do we know? We know that there are no other x-intercepts. So because there are no other x-intercepts, this obviously is not turning down, right? It means that it has to just go up like that, and that would be the rest of that portion of the graph. You could plug in like a -1.5, -1.9, something like that, and you would see that this would be going up like that. Now on our right-hand side, if we plug in a number like x equals 5, just something right on the other side of that asymptote, I got 4.6 for that, meaning that it's going to be positive. It's going to be up here, and then we know based on our knowledge of the horizontal asymptote that that's what the rest of that is going to look like. All right, so this is something you kind of really understand. That horizontal asymptote is going to be a huge help with this stuff. Maybe we'll do one or two more together. If you're feeling confident with these at this point, by all means, try them on your own, and then you can pause the video and watch the rest, or just check the key at the end. But this one is a little bit interesting. The reason being, if you see that x squared plus 1, this is something that you can't factor. Obviously, the 5 you can't factor either. So there's no values of x that we can plug into that are going to make our denominator 0. So that basically means that all three of these things are all going to be none. There's no x values that are going to make our denominator 0. Horizontal asymptote, the degree is larger in the denominator, so it's y equals 0. Our x-intercept is none, right? If we set our y equal to 0, there nothing would work there. And then our y-intercept, if we set x equal to 0, we get 0, 5. So we got 1, 2, 3, 4, 5. We have our y-intercept our horizontal asymptote going across at y equals 0. So based on our knowledge, I keep going back to this horizontal asymptote and what it actually means. We know that this graph, we have this point up here at 0, 5, but we know as we go off to infinity and off to negative infinity with our x values, we are going to get closer and closer to our horizontal asymptote. So you could check a couple points, like if we plug in a 1, see we get 5 halves, so we get like a 2.5 for that. If we plugged in a negative 1, we're going to get the same exact thing. And if you kind of plugged a few more, if you weren't feeling confident with this, you could. But it's really just a little bit of a bell curve right there. And then it goes back towards that horizontal asymptote. So definitely one of the stranger ones. But if you understand where everything comes from and how these graphs are formed, hopefully makes sense to you. All right, try one more all together here, and then I'll let you guys do some work on your own here. This is already all factored for us, which is great because that's already our first step. Cross out these x plus 3's and let's label our discontinuity. So we got x equals -1, x equals -3, and x equals 2. Let's break down which ones are vertical asymptotes, which ones are holes. So the vertical asymptotes are the ones that remain, so x of -1 and x equals 2. The hole in the graph is the one that crossed out, so that's our -3. If we plug that in, comes out to -1/10. So I know I'm going a little quick on where those are coming from, but it's because I just did them previously. What I'm doing is just taking that -3 and plugging it in for my x values into the simplified version to get the corresponding y. Degree is larger in our denominator, so horizontal asymptote is y equals 0. X-intercept, that's our factors of our numerator, so -2, 0. And then if we set x equal to 0, we would get -1 out of that. So a whole lot of stuff here. So try and get my vertical asymptotes correct this time. We got x of -1. And then we have x equals 2. We got y equals 0 coming across. All right, we got -3, -1/10. So 1, 2, 3, we'll say that's right about there for the whole, exaggerated a little bit. I know I have an x-intercept of -2, 0. And then I have 0, -1 in the middle here. All right, so this one's a little bit unusual because as you can see, it looks like this is obviously coming down like this, which it is, but then I've been talking about this end behavior. So it's not like this can just continue on like that. That is not going to happen. If I erase this, it's a little bit of a weird case. It crosses through our horizontal asymptote, but if it does that on the outsides, it always is going to return to them as it goes off to infinity or negative infinity. So a little bit of a special case there. We don't see it very often, but it is possible to cross that on the outsides and then know that it's going to go back to it. In the middle there, we've talked about using some hints. So in this case, there's no x-intercepts other than that -2, 0. So I know don't need to worry about this going through. And then if I plug in a point on the far right, if I plug in an x value of 3, that becomes a positive value for my y. So I'm confident in drawing in that right there. So a lot going on with this lesson. Obviously, there's kind of no rhyme or reason when you're looking at just the original function as to what's going to happen in between when you have two vertical asymptotes and stuff like that. So just understanding the horizontal asymptotes, plugging in points to check, all of that stuff is really useful when you are solving these. If you're allowed a calculator, use the calculator, plug it in, take a look at it. If you're not, then obviously knowing how to get all of these things is very useful. that's going to do it for the lesson here. I know there's one more problem on here. I'm going to have that be an exit slip for my class, but for your own homework tonight, just refer to your classroom teachers and they can let you know what to do. All right, thank you very much.